Hey, I'm going to show you how to test open source models on your local computer. This is a tool called LM Studio. I found this is working really well for me, specifically on my M2 Mac, although it should work on on your PC as well. I'm not going to go through the download instructions because I think if you want to install it, you should just go to LM Studio AI and then you can download here. It should just work. It worked straight away for me, which is why I was really attracted to it. But I would say that the Discord is really good. People got back to me straight away when I wanted to know how to make sure he's using my GPU on my computer. It's a really active community and it just makes things super easy. Cool. Now, the way this works is you need to search for a model. Say, for example, if you wanted the new Mistral model, which is a pretty small model, you can run it on your local computer. Then you can search and it comes up with the Hugging Face hub. You can see which ones have the most downloads, and this is the Mistral model with the most downloads here, most comments. What you're looking for, and all of this will not make sense to you if you don't know anything about these models, but let me explain it real quick. So the bloke is basically like a guy or an organization that gets some funding from, I think, A16Z, but he basically just posts these fine-tuned models on Hugging Face all the time. All the new models that come out, he'll put it on Hugging Face, or also train kind of new fine-tuned models as well. So when you see this one is Mistral Open Orca, that's trained on the Open Orca dataset, it's fine-tuned. And then there's also Open Hermes, Yarn, there's a German one. So yeah, these are all fine-tuned models, but the main one that we want to use here is Mistral 7B Instruct. That is the chat version of the Mistral model that was released open source. So if you want the normal Mistral model, that's that, but that's similar to GPT-3, where you have to do a lot of prompting to get it to talk back to you and follow instructions, whereas the chat model is much better out of the box. And typically I just download the GUF file as well, because there's different file formats. It doesn't really matter that much, but that's the one that I've been using and it works fine. The quantization stuff over here, this is basically a technique to remove some zeros from the numbers in the model, like the parameters. It makes it slightly less accurate, because if they have, say, 7 billion parameters, if you remove a few zeros from each parameter, it makes that parameter a little bit less accurate to fewer decimal places, but it really improves the size and the speed of the model. Typically what I do here, and these are different quantization techniques, but what I typically go for, I ignore everything, I just go for the KM, Q4 KM. And there's, you can see for every single model, there's a Q4 KM. And you can see I've downloaded that as well. And the reason why I choose that one is it usually says it's recommended. If you go for a bigger model here, so you can see the Q8 here is 7 gigabytes, a little bit bigger. And then there's also KS versus KM, but I don't think you need to really think about it too much. The other thing is that you can click through to the model card here if you want to read a bit more about the model and why it was made. The next thing you need to do, so actually let me just stop the server here and just show you what you can actually do. You can actually run this just like ChatGPT, but you're running it locally in the browser, or actually in the application, and it does a pretty good job. And you can export as screenshots. The other cool thing is it tells you token speed, stuff like that, and basically you just need to load the right model and then choose the right preset. Here I've chosen Mistral Instruct because each of these models, they require a different way of sending the prompt, and this will basically just send the prompt in the right format. So this one, it needs to have the system message and then this inst token, and then user message, and then close the inst token, and then the assistant message. It formats that for you, otherwise the model doesn't tend to work. You see it adds all this. This is the system message. You can change this if you wanted, but I've kept it there. Now, if you're gonna chat to this, by the way, in here, you can do that. But one thing I would say you want to do is if you go into tools, and then instead of, here we go. Under tools or model initialization, there's a couple of options here. So one is keep the entire model in RAM. What that will do is basically, it could make your computer crash, but it will make sure that it goes as fast as possible. That's one thing you can do. But the main thing you need to do is click here. So I have Apple Metal GPU clicked, and that's going to basically
mean that it will use my GPU while the model is generating, so it'll be a lot faster. Anyway, that's the main thing you need to do. Anyway, but what I'm going to show you is how to use it locally in your code. The cool thing that they did is they made it, I give you an option to set up a server, and this is in port 1234, with logging and everything, and automatic prompt formatting, and basically they've mirrored the OpenAI API. Here I have Mistral Instruct, and I have Mistral Instruct preset here, but it's given me an endpoint like this chat completions that I can call. They actually also mirrored the OpenAI API, so all you have to do is change the API base to this URL, and then all of your OpenAI code should work. However, this is already outdated because they updated to version 1 of the API for OpenAI. So if you've already upgraded, then this won't work. So that's why I'm using this curl request here, because that's just more generic. It's not using the OpenAI library. So anyway, that is what we're going to be making use of today. And now I'll just jump over to the code. So a couple of things I've done here is I've imported requests, I've imported JSON library, and then I've set the URL. So this is localhost 1234. So this is running on my own local computer. And then the format of how you send to OpenAI is the same as how you send to this model. And the LM Studio is going to do all the hard part to split it out for you. So I'm just going to run that, and it's going to format the prompt for me and send it back. And here we go. Yeah, and this is the response. So just the same sort of response you get from OpenAI. So that's pretty cool. Now, the code that I've run here, this is just how you would test these types of models. I've just brought in here a time so I can measure the latency, and then I've also brought in matplotlib so I can graph it afterwards. But the key here is that I test Mistral 7B against GPT 3.5 Turbo and against GPT-4. And for GPT-4 and GPT 3.5 Turbo, I'm going to be calling the completions API. But for Mistral, it's going to be exactly the same, but it's just going to be calling my local host. So I've set up this function here. The default is 3.5 Turbo. But basically, what it does is it gets my API key for OpenAI, puts the prompt in here, in the system prompt, and then we get back the response. And here's the system prompt. It could actually be the system prompt, or it could just be the user. So if you set user here, and then you could set the system prompt separately if you want. I'm just going to set the system prompt as you are a helpful assistant. And you can make that whatever you want, but this is going to set in the prompt as a user. And then it's going to fill in the temperature and everything like that as well. But this is my prompt. This is what I was using before. And what it's going to do is it's going to run through each model, and then it's going to create an object to hold the latency and the response, or the responses. And then it's going to go through 10 times and call the model 10 times. It's going to time it. So it's going to start the timer and then end the timer after it gets the response back. And then it's going to add those to the object. And then basically we're going to have then this results object filled in with 10 calls to each of the models alongside the latency. So then we're just going to plot it afterwards as well. So I'm just going to run that, and that's going to create the chart at the end. Now, the reason why you'd want to do this while we're running this is just that there's a few different reasons, actually. One is, if you can get better results from an open source model, or if you can get at least good enough results from an open source model with your prompt, then you might want to be using that locally instead. Like, you don't need the internet to use this, which is very cool, because if you're on a flight or you have spotty Wi-Fi, you can still be using an LLM locally, which is pretty good. The other reason why it's useful is that it could be a lot cheaper, right? If you are hosting this yourself, you're just paying for the inference costs, you're not paying any markup to OpenAI. So that can be really helpful. A third is flexibility or freedom. So if you're building a business and you're worried about things going wrong at OpenAI, what happens if they fire Sam Altman again, or some sort of disruption happens? Like, their API goes down quite a bit. So having a backup, I think, that's open source, that it can't be taken down. It's literally just code on your computer. So nobody can stop you from using it, which I think is really powerful. And you could build a business around that as well. You can host it on your own servers, and then you never have any issues with reliability from other hosts. Especially if OpenAI starts having to curtail
some of the uses of its API because it gets pressure from Microsoft or whatever. So anyway, that's all run now, and we can see the difference. And we can see that Mistral was faster than GPT-4 on average. So this is latency, is how many seconds it took to get back the response. And then you can see 3.5 Turbo is still a lot faster and pretty cheap as well. The 3.5 Turbo, this probably costs less than a penny. So anyway, that's pretty interesting. We could also, because now we have this results object, we can just see what it came back with. Here are the responses. You can see that with Mistral, it was pretty good at following instructions, although sometimes it does put the numbers in here, number 1, number 2, number 3, and that's not what we wanted. Whereas if you look at, say, here are the responses for GPT 3.5 Turbo, it never did that. So that is a little bit more reliable. And then GPT-4 obviously is really good. The other big benefit of doing this multiple times is you just see how reliable it is and how often the same names come up. So pretty cool that OmniFit shoes, OmniFit comes up for all of them. OmniFit walkers comes up pretty commonly for GPT-4. It's actually more deterministic, it feels, than the other responses. So seeing this just gives you a good sense of what are the differences between the models. I would say that Mistral is pretty good here, though, especially for a tiny model. If you think about GPT-4 is like 1 trillion parameters, GPT 3.5 I think is like something like 50 billion parameters, and Mistral's only 7 billion parameters, and it still it hangs tight. Some of these names are even better, actually. I think AdaptiFit, so that's AdaptaFit, which is interesting. OmniFit shoes, but there's also like FootMorph, I think is pretty creative. And then FootMate, that's cool as well. I don't see that anywhere else. Yeah, I think it's definitely a contender and it's worth checking out. So yeah, test your prompts and hopefully you get good results.